All right, so if you're out there building AI agents, you've probably spent a ton of time trying to perfect your prompts. But what if the real key to building truly smart, stateful agents isn't about that one perfect prompt, but about everything you do around it? Today, we're going to move beyond just prompt engineering and dive into something way more critical: context engineering.
You see this cluttered jar here, stuffed to the brim with anything and everything? This is the perfect metaphor for how a lot of AI agents get built today. That overflowing jar, well, that's your context window, and it's causing two huge problems that are absolutely throttling your agent's performance.
So problem number one is what's called context pollution. Just imagine your agent has, say, 20 different tools it can use. It can check your calendar, search your Google Drive, you name it. Now, if a user asks something that only needs 2 of those tools, the old way of doing things still crams all 20 of those super long tool definitions into the prompt. This doesn't just waste a ton of precious tokens, it actually shrinks the space your LLM has for, actual thinking.
And the second problem? It's even worse. It's expensive data transfer. Let's say one tool creates a massive 8,000 token summary of a meeting. The standard flow makes the LLM take in that entire summary, only to immediately pass it along to the next tool. As one developer so perfectly put it, that's like hiring a PhD to photocopy documents. You're using a brilliant reasoning engine for a simple, mindless copy-paste job.
See, these issues all boil down to one fundamental truth. Large language models are, by their very nature, stateless. Their entire universe is confined to the context window of one single API call. If it's not in that window, right here and right now, poof, it just doesn't exist for the model in that moment.
Okay, so this is where we pivot. We've identified the problem, now let's engineer the solution. To build agents that can actually remember, learn, and adapt over time, we need a much more dynamic, much more intelligent way to manage that priceless context window. What we need is context engineering.
At its heart, context engineering is not a static, set it and forget it kind of thing. It's an active, ongoing process. It's all about dynamically putting together and managing the information an LLM needs for every single turn of a conversation. It's about giving the model exactly what it needs, precisely when it needs it, and absolutely nothing more.
And really understanding this separation is key. Think of it like a chef in a kitchen. Prompt engineering is like writing a fantastic recipe. You craft it once, and it's set. But context engineering, that's the chef's mise en place. It's that whole process of gathering, chopping, and preparing only the ingredients you need for the dish you're making right now. It's totally dynamic, and it happens for every single task.
So let's tackle the first big challenge. How in the world do we manage a long, evolving conversation without completely overflowing the context window? How do we make these interactions feel like they have a real memory? To do this, we need to think in terms of two concepts: session and memory. Your session is like your workbench. It's messy, it's got all the notes, all the tools, all the scraps for the project you're working on this very second. But when the project is done, you don't just shove that entire workbench into a closet, right? No! You create memory. You clean up, you pull out only the most important final documents, and you put them away neatly in a filing cabinet so you can find them later.
And to keep that workbench from getting completely out of control during a long project, we use what are called compaction techniques. The simplest strategy is truncation, where you just decide to only remember the last, say, 10 turns of a conversation. A much smarter approach is summarization, where you have an LLM periodically create a condensed summary of the older parts of the chat to save space.
Okay, so we've got some good techniques for managing the conversation history. Now let's jump back to that other massive problem: making tool usage efficient, scalable, and, well, actually intelligent. This quote just hits the nail on the head, doesn't it? We're forcing our agents to carry around this enormous, heavy instruction manual for every single task, when all they really need is to read 2 pages. It's a huge waste of their cognitive space.
The solution is actually a pretty radical shift in thinking. Instead of treating tools like static definitions you have to stuff into a prompt, we start treating them as discoverable pieces of code. We organize them in a simple, clean file system, like files in a folder, that the LLM can browse and understand all by itself.
And the logic behind this is it's beautifully simple. First, you just organize all your tools as code functions in a file system. Then, and this is the magic trick, instead of giving the LLM all 20 tool definitions, you give it just 2, a tool to browse the files and a tool to execute code. And finally, you just let the LLM do its thing. It can now discover the tools, read their descriptions, and import only the specific ones it needs for the task at hand.
So, we've gone over the concepts, and they sound pretty cool, right? But what's the real-world payoff for all this engineering work? Well, the numbers are pretty staggering.
A team decided to put this whole tools as code thing to the test. They gave it a realistic task: download a meeting summary from one service and then upload it to another, all while having 20 different tools available in the background. So, how much of a difference could it really make?
94%. A 94% reduction in the initial context tokens sent to the model. Just let that sink in for a second. By simply not force-feeding the LLM every tool definition right from the start, the prompt became dramatically smaller, cheaper, and way more focused.
But hold on, the full story here is even more impressive. That 94% reduction, that's just the tip of the iceberg. Look at the final tokens row, an 86% reduction. And do you know why? It's because that huge meeting summary, it never even entered the LLM's context. It just flowed directly from one tool to the next through the code, making the whole process incredibly lean and efficient.
The power of this approach really boils down to 3 huge advantages. First, you get super efficient context management because the LLM only loads what it actually needs. Second, you get direct data flow, which keeps those big, clunky data blobs out of the context window. And third, you're actually playing to the LLM's strengths. These models are naturally way better at writing a simple import script than they are at generating weird, complex JSON tool calls.
And that brings us to the final question you should be asking yourself. With the traditional methods, that context window, it often becomes a liability, right? A bottleneck that you're constantly fighting against. But with smart context engineering, it transforms into what it was always meant to be: a powerful, focused asset for building truly intelligent AI.